All right, well, the other rule that we need to go into, we need to talk about the quotient rule. And unfortunately, the quotient rule is more like the product rule than it is the sum and the difference rule. If I've got a function, say y equals f over g, so I've got two things divided, quotient. I've got a quotient. Like I said, there's more complicated to it than just doing the derivative of the top divided by the derivative of the bottom. Turns out it goes like this. The derivative here is let me think. Do I want to do? Let me just show you. Let me show you that it is not derivative of the top over the derivative of the bottom. What were the two I was going to do? 8x to the fifth. All right, so let's say y equals 8x to the fifth over 2x to the third. If this was true, then the derivative would be equal to what? 40x to the fourth divided by 6x squared, just the derivative of that over the derivative of that, which is, can reduce that. That's, I can only reduce it by 2, can't I? 20 over 3. Then I can reduce those to be x squared. That is not it. Because, notice here, this is equivalent to 4x to the second, right? Divide that, that's 4. Divide that, that's x squared. So the derivative is 8x. It's not even close. That's not even close. Okay. Don't do that, because it's not even close. Here's the way you do it if you treat them as separate ones. Turns out you take g times the derivative of f minus f times the derivative of g over g squared. Isn't that a lovely picture? Let me just go ahead and tell you how this works, or how you can remember it, or how helps me remember it anyway. Think of it, you know, we did first and second on the product, but think of it as low and high. I'll abbreviate them, LOW and HIGH, but let's abbreviate them so I can write it easier. Low and high. Whoops, did that backwards, didn't I? High, low. Okay, that's better. This one's the high, this one's the low. High's on top, low's on bottom. All right, messed it up already. What this says, the way helpful to remember it, is, isn't this low? And that's the derivative of the high, low d high, minus, what's that? High d of the low. And that's low squared. Okay. That's how I remember it, believe it or not. Low d high minus high d low over low squared. It's kind of like off the dwarves off to work there. Low d high minus high d low over low squared. It's just a little catchy thing to help you remember it if you have trouble remembering it. You can come up with your own thing, but that's one that's helped me anyway. Okay. All right. Yeah, let me just show you that it works. Whoops, erased it here. 2x cubed. Yeah, 2x cubed. All right, that was, the derivative was, what was it, 8x? Okay, let me just show you that it works. All right, so I do the low. So just take the low as is times d of the high, that's 40x to the fourth, minus the high, which is x to the fifth, times d of the low, which is 6x squared, over low squared. And so that comes out being 80x to the seventh minus 48x to the seventh over, square that, you get 4x to the sixth. Look at how this works. 8, that's like terms, so I got x to the seventh, 480 minus 48, is that 32? Over 4x to the sixth, which is, if you reduce that, that's 8. Subtract that, you got it. It works. And I realize, yeah, on that one, this isn't the way you'd want to go. I realize that. But there's going to be lots of them where we're going to have to use this. So just showing you that it works one way. There's, like I said, there's little tricks to showing you how, where it comes out. Actually, you can use the product rule there to do that one. But, okay. All right, so let's see some uses for this. Let's say we've got y equals 3x plus 4 over x minus 2. Turns out this one comes out pretty nicely here. But do you see here, this is one where I pretty much have to use it. There are tricks I could use, but this one is a good candidate for my quotient rule, isn't it? Because I've got a top function over a bottom function. I got a high over a low. Yeah, so I'm going to use a quotient rule. How's the quotient rule go? Low d high minus high d low. All right, so I take the low, x minus 2, times d of the high. What's d of the high? 3x plus 4. The derivative of that would be just 3, isn't it? Derivative of that's 3, the derivative of that's 0. So d of the high is just 3. Minus then, take the high times d of the low. What's d of this x minus 2? D of that is 1. Derivative of that's, yeah, just 1. Derivative of that's 0, so d of the low is. Then the bottom, now the bottom is just low squared. Not the derivative of the low squared, it's just low squared. The low is x minus 2, so low squared is x minus 2 squared. Cleaning that up, like I said, this one actually cleans up nicely. Do you have to multiply that by 3, so it'll be 3x minus 6. This, well, it's times 1, so it's just minus 3x minus 4, isn't it? This right here, over x minus 2 squared. Well, this one, it won't always happen this nicely, but 3x minus 3x, those are gone. Minus 10 is all I have on top. Okay, minus 10 over x minus 2 squared. All right? Quotient rule. All right, let's see. Here's another one. Yeah, we haven't come across this yet. All right, so let's say I've got y equals ax squared over bx plus c. What's the derivative there? Well, don't have to use my quotient rule here. I've got ax squared divided by bx plus c. So that is where we would do our quotient rule. How's the quotient rule go? Well, I take low, just the low as is, bx plus c, times d of the high. Now, I do this one on purpose because we haven't had one where we have like an ax squared. And usually, when you have ones that look like this, where I've got multiple variables, in this case, obviously the x is the x like we know and love it. The a, b, and c, treat those as constants. So they're just like numbers in front of these variables here. Okay, so that special note there. If you've got like an ax squared, at squared, the a is a constant. B s squared plus cs, the b and the c, those are constants. So if you have those numbers instead of coefficients, treat those as constants. What does that mean? Well, what is then the derivative of ax squared? If that's a constant, the derivative is going to be 2ax. That's right. With me on that? Because I'm just doing the derivative of x squared, which is 2x, times the a would be 2ax, or a times 2x. All right. So that's, all right, then what? So I've got low d high minus high d low. So I do the high, ax squared, times d of the low. What's the d of this? It's going to be b, isn't it? Derivative of bx would be b. Derivative of c is 0 because it's a constant. Okay, over low squared. Yeah, I think we can clean that up a little bit. Multiply this and this in. So that would be 2a bx squared plus 2acx minus, and let's write this one, a bx squared over bx plus c squared. Yeah, this does clean up because I've got this minus, aren't those like terms? abx squared. So it's 2 minus 1. So that'd be a 1 abx squared plus 2acx over bx plus c squared. I just combined those two to get that.